Hello everyone, and welcome to the 47th C programming tutorial. In this tutorial, I'm going to be covering how we can work with recursion in C. Now, recursion is a fairly simple idea. It's basically the idea that you call oneself within oneself. So it's basically like looping or repeatedly calling the same thing. That sounded pretty confusing when I just said that. So let's make an example. So my code will speak for me. If I made a function called recurse, like such, and I call it like this. Now, what do you expect might happen? Well, our main function starts, right, and it calls recurse. Recurse then calls recurse, and then it calls recurse again. And then if you can guess the next time, it's going to call it again. So the whole idea here is that we keep calling the same function, right? The function that we're in calls itself, essentially. So that is a very basic idea of recursion, but obviously this is not a useful example for it. So let's talk about some useful examples. And, well, just a fair warning, I guess. The examples that I'm going to use are fairly basic, introductory-like examples. And you got to start somewhere. So this is, I think, they're the very common examples you'll see online if you try to search for recursion. But nonetheless, this is that. If you want to know some common uses, though, you can further branch out. I know I haven't talked about trees yet, but trees. The idea with trees is basically a data type, a data type. Yes. I'm losing my mind. But anyway, where you would have a left and right node essentially to sort through data. And how you would traverse through the tree is you would repeatedly call a function. So you would call a function like traverse, and you would keep calling like go down the left node, right, until it's not there anymore. And then the function would return, and then you'd go down another way, right? So the idea is that you would keep calling the function. Though this is an example of recursion. Another example is in, I believe, quicksort, merge sort, maybe also. I can't really remember my sorting algorithms, but nonetheless, both or either one of those has an example of recursion, and I'm sure there are multiple sorting algorithms that use recursion as well. Anyway, we haven't talked about any of those, so I'm not going to start in this tutorial because recursion is complicated enough. So let's start with our simple factorial example that I was mentioning before. And just in case you don't remember what factorial is, it's basically this thing. So this is 4 factorial. And 4 factorial is represented by 4 times 3 times 2 times 1. Essentially, whatever the number is, and then multiplied by decrements of 1 subsequent to 1. And that probably was not proper English at all. But anyway, you get the idea. If we had 10 factorial, it would be 10 times 9 times 8 times 7, all the way down to multiplying by 1, and that's it. 0 factorial, if you're interested, is 1, and I believe negatives do not exist for factorials, so that's that. Anyway, so my factorial example assumes that you are using 0 or above. All right, anyway, that's that. So in a while loop example, this is not recursion, this is just a simple while loop example. And this is, so if, for example, I called factorial 4 in this case, you can see that we have this initial value, and this value is just holding on to the value of our factorial, basically, as I multiply by all the numbers. So it starts out at a value of 1. That's just for convenience because I got to start with a value when we're multiplying, and 1 is what I want to start with. So if I multiply by n, right, n starts out as 4 if I call 4 factorial. So 1, which is my start value, I multiply 1 by 4, and I get 4. So another way I could have done this is assign value to be n to start, and then loop through it that way, but you get the idea. Anyway, so we'd say value multiplied by 4 is now 4. I decrement n, so now it's 3, and I go back through my while loop. 3 is still greater than 1, so I now multiply value, which is 4, multiply that by 3, 3 times 4, 12. So value is now equal to 12, and I subtract 1 from n. N is now 2, so 2 times 12, which was 4 times 3, 4 times 3 times 2, or 12 times 2 is 24. and then I'm done. So that's my factorial. 4 factorial is 24, and then I return that value, right? So I didn't have to go through the 1 because 1 times anything is just the same thing. All right, so yeah, that's that. Cool. All right, so that's the while loop example. Hopefully you get the factorial. If you don't understand it, then please, look over or look on the Googles if that wasn't enough. All right, so what's a recursive solution for a factorial call? Because we can make using, instead of a while loop, we could use recursion to solve our factorial dilemma. So if I wanted to calculate the factorial using recursion, I can make an example like this, where I'm calling factorial, and let's say in this example I call factorial 4. So I'll just scroll down to my actual example part. And so let's say we're calling factorial 4. So what would happen? Well, let's just run through this. So 4, if n is equal to 4, 4 is not less than or equal to 1. So this is false, and we will go down to this part, right? So now we are going to return 4 times, then we call factorial again. So we don't really return anything yet, right? Before we can return anything, we've got to call factorial once more, okay? So when we do this, we're calling factorial with the value that's 1 less than n, right? This is the same sort of idea with our while loop. We would multiply the value, right? So we'd have 4, and then we would, the next time through, multiply it by 1 less. So that's why we call factorial n minus 1, because we want to multiply it by the value 1 less. I could also have put n minus minus in here if I wanted, but you get the idea. Anyway, so n minus 1, right? Cool. So now the next time through, we would have a value of 3 for n. So factorial of 3 is less than or is greater than or equal to 1, so that's false, right? It's not less than or equal to 1. So then we would return n, which is 3 in that case, right? So 3 multiplied by factorial of 3 minus 1, which is 2, right? 1 less than the previous. Then we call factorial 2. The if statement's still false, and then we call the return. So now we have n is equal to 2, multiply that by factorial of 1 less. All right, so now we've hit what's known as the base case. So this case right here is known as the base case, which I should have said earlier. But the base case is essentially the case that allows you to exit the recursion. So in my earlier example with that recurse function, which, like I said, I don't know if recurse is a word, but with the recurse function, we would never exit, right? There was never a return in that example. So there's never a point that we could return. The base case makes that point that we will return somewhere, right? There is a point that this recursion will return, and that is important. Otherwise, you will have an infinite loop. So once we finally hit factorial of 1, when we call factorial 1, then n is equal to 1, which is less than or equal to 1. So this returns 1, like I denoted right here. All right, so now we basically go back through all those calls that we made. So we made a call, right, called factorial 2 minus 1, which was factorial 1, and that returns 1. So this call right here, which I'm trying to highlight, okay, apparently I can't, there we go, factorial of 1, that returned 1. So then we have a return call 2 times 1. Cool. So then if I back this up one more time, we had factorial call of factorial 2. Factorial 2 was equivalent to returning 2 times 1, which was 2, right? So now if we go back up one more time, we had return 3 times whatever this call was, which was times 2, whatever this call was times 1. So we had 3 times 2 times 1. All right, so that's what that call was. And then we just returned that by multiplying by 4. So we had 4 times 3 times 2 times 1. And that is the last call we ever made, right? After that, there was no other function call. So we just return. And that was the last return. So we returned the number, which was all those things multiplied together, and that is 24. All right, so now that we're done with that, let's go ahead and make that example. So we'll call int factorial and pass in an int n. So we make our base case if n is less than or equal to 1. then we will return 1. If that's not the case, then we will return n multiplied by whatever I'm looking for, which is factorial of n minus 1. There you go. All right, so if I was to print this out in a handy dandy printf, it would look like so. So let's say I use factorial 5. Factorial 5 is 120. So if I did factorial 5, I would expect that I get back 120, right? So I can run this, and as you can see, my output is 120, as we expected. All right, so that's the fairly simple example of recursion, and just the whole idea. I think the easiest way to kind of understand it is to just keep going through it, and you'll soon wrap your head around the idea. This next example might help a little bit as well. Maybe it'll just make it worse, but I think it will help. So this next example is going to be not returning anything. We're going to make a function called printInt. So in this example, we will not be using printf at all to print to the console. And you might be wondering, ooh, how do you do that? Well, there's a function. I keep saying method. I'm bad with that. But I mean function. There's a function called putchar, which simply puts a character or prints a character out to the output. So in this case, I'm going to just write something out here. So essentially what we want is that putchar will just print out some value, right? Now if I called this, it would just print out a value of 0. Now the idea is how could I make this print out the value that I want? Well, I would just add n to it. So if you remember back to when we learned about characters or the ASCII character set, you might remember that there are different character values assigned to, or basically numbers assigned to different characters, right? So there's some kind of numerical value assigned to the character 0, right? And if I add, let's say for example I add 4 to it, then I'm just going to get the number 4, right? Because the numbers are all in a row. So whatever the number value is of 0 character, then I will add n to it. So if n was 4, then I would print out a value of 4. Just to give you an example of that, let me do \n here. If I do another print, actually I don't want to do printf at all. I just want to call our printInt function, and I put a value of 6 in here. All right, so if I call this, putchar would be the value of 0 character plus 6, which would move the value. So let me just see what the value, I don't know what it is. The value of 0 character is something that I don't really know off the top of my head, but then we add 6 to it and we will get the value of the 6th character in the ASCII table. All right, so if I run this, you'll see that we get the value of 6. Okay, simple enough. Now, you might remember with the ASCII character set, though, that you only have the values of 0 to 9, right? For obvious reasons, we don't have more than that. So the numbers from 0 to 9 are the only ones we can handle. So if I was to, say, change this to 12, then I'm going to run into issues, right? I'm going to print out some other character. So I get this character, which is the less than sign. So I added 12, which goes beyond the number character set. And so I'm going off into other characters. So the whole point of this is that putchar, right, our n value has to be somewhere between 0 and 9, right? If I add 0 to the 0 character, I get 0. If I add 9 to it, I get 9. Pretty simple. All right. So the idea is if I was to print something like 123, how am I going to be able to print this out? Well, good question. Well, we could use the whole point of this tutorial, which is recursion. So let's make an example where this will actually print the number out in reverse. So when we go to print this, it's going to print out 321. You might be wondering why I'm doing that, but just bear with me. So our condition to start will be whenever n is greater than or equal to 10, that we want to do something else, okay? If the number is less than that, so I'll make my else right now. The else case is kind of like my base case. This is the case that will happen when everything's said and done. Okay, so this else case right here is basically my base case. So whenever n is essentially less than 9, right, I could have written that out too. But whenever n is less than or equal to 9, then this else case will execute, and that means I can just call put char. So I'll call 0 plus n, right? And n in this case is obviously somewhere from 0 to 9, or it would be negative, but we're not. Let's just assume that we're not going to use negatives. I don't want to deal with checking for that. But anyway, let's assume that we have something from 0 to whatever. If the value is less than 10, right, then our else statement will execute and our put char will be called, which is fine. That's what we want. All right, so what happens when our value is greater than 10, though, right? That's when we're going to run into an issue. So what we want to do is essentially take off the last digit of the number that is passed in. So if we pass in 1, 2, 3, I'm going to take off the last digit. And remember, we're going to print this number in reverse. So I want to print this number in reverse. So to do that, I have to get whatever the last digit is, right? If I print 1, 2, 3 in reverse, I'm going to get 3, 2, 1. So how can I get the value of 3? Well, pretty simple. I can just say int last digit. I'll just make some variable here. And to get the last digit, I will just take the value of n and mod it by 10. And modding by 10, just to remind you, we'll get the remainder, basically, when I divide this number by 10. So in the case of 123, the remainder of this would be 3. So if I can only divide 123 evenly if the number was 120. 120 divided by 10, right? That works. But 123 doesn't divide evenly. So the remainder of that would be 3. Remember, this is, we cover this very early on in the C series. So anyway, if I say n mod 10, I'm taking whatever the last digit is on my number. Then, since that number, right, ranges between 0 and 9, I can print it. So 0 plus whatever our last digit is, and I will print that out. Cool. So now whatever the last digit is, whatever we pull off the end of our number, we're going to print that out. Then we want to call printInt again. This is where the recursion comes in. Yippee. So now what do we want to pass in here? Well, we chopped off, or we pulled off that last number, right? So we took off the 3 from 123. So we want to only pass in 12 now, right? We don't want to pass in 123 again because we already used that. So we just want to pass in the 12. Well, how do we do that? Well, we just divide by 10. So if I say n divided by 10, right? 123 divided by 10 is 12, right? Without the remainder. Or in other words, if I can only divide 120 evenly. If I divide 120 by 10, I get 12. So then I call printInt again, sorry, and I would have the value of 12. And so I would print out, well, I wouldn't print out anything. I call my if statement, and in this case, I'm still greater than 10, right? 12 is greater than 10. I have to pull off that last digit again, which is 2, print it. So now in my output, I had a 3 that I already printed. Now I'm printing the 2, and now I want to call printInt again. I divide it by 10. 12 divided by 10 with integer division is 1, right? 10 divided by 10, 1. So now printInt is called again with a value of 1. So you might now say, well, okay, n is now 1. Well, that's cool. Our if statement now is not true, right? 1 is not greater than 10. So now our else is called, and we call put char, and we had a value of n, which was 1. So the 1 gets printed out. Yay. So let's go ahead and run this and see what we get. So as you can see, we get a value of 3, 2, 1, as I said. Cool. All right, so that's dandy. Now, what if I wanted to print this number in the normal order that it appears, which was kind of the whole point? Well, it's pretty simple. I can just change where I'm printing the number. So I'll print it after I call the recursion. So you might be wondering, well, what does that mean? Well, let's kind of run through it. So if I call print 1, 2, 3, I'm greater than 10, 123 greater than 10. I pull that last digit off, I save it. So last digit is now saved, and then I call printInt again. So now it's just kind of stored, right? So every function kind of keeps its state, and then I call the function again, right? it's similar to the main function. If you think of the main function, right, it's always sitting there. It's sitting there until the end of the program. So I can do whatever I want in the main function, and then I can, go off and call some other function. And then if I came back, the state of the main function is still the same. So recursion really isn't any different. I'm just calling the same function in this case. So everything still stays here, right? I pull off this last digit, which is a value of 3, and then I just call print_in again with a value of 12, right? 123 divided by 10. So print_int is called. So value of 12, I pull off the last digit, which is 2, and then I call print_int again. And so I have now a value of 1. The else is called, right? And put_char is called, and n is a value of 1, so we get a value of 1 printed out. That's the first time we print anything, right? That's the first time we've called put_char, so that's the first thing that gets printed out is that value of 1. All right, so now what happens? Well, that print_int is done, right? So now we kind of return back. We called this print_int in one of our print_int calls, and now it's done, so we return, right? We continue on to the program, and we call put_char. So the last place where we were, we pulled off a digit of 2, and so we put that, right? This print_int is now done. All right, but we still had another print_int that was called before that. So this print_int call was done, and we return again, right? Back into the old the first print_int that we ever called. The first print_int that we ever called still pulled that last digit, which was a value of 3, and then it prints that. So then it prints out the 3. So if I was to run this, you can see that we get a value of 123 that is printed out. All right, so that is, pretty simple recursion examples for you. If you want to see some kind of more in-depth stuff, though, I'm going to show you just before we leave how you can use breakpoints to kind of analyze this a little further, which I think is fun. So if I left my breakpoints on these different places here, I'm going to put one here. Yeah, I'm just going to delete this one, I think. So what does a breakpoint do? Well, basically a breakpoint is a place where your program will stop. And actually, I'm going to remove that one. I think I'm just going to leave it there. I don't really know. I'll figure it out in a bit. But a breakpoint is just where you stop at that line of code. So while I'm running this program, when this line starts, then I'm going to stop right at this line. Okay. So what this means is that I'm obviously done now, right? And I'm going to wait, and I can look at all the state of all the variables at this breakpoint, and it will show me the value of n, for example, and the value of last digit, and it will give me all that information. So then I can continue the program, and it just continues until it hits another breakpoint. And then, so once it hits this, it'll stop, let me know the state of everything, and then I can continue. So breakpoints are kind of fun to play with. But anyway, let's kind of show an example of how this works. And actually, let me rerun this. Stop that, and I'm going to put a breakpoint here. Actually, I haven't made up my mind what I'm doing. But anyway, as we can see, so we've made our first call to print_int, right? So we started with main, and as you can see, we called the print_int function. Then we called print_int, and we stopped right here. All right, so what happens now? Well, now we call print_int again, right? So if I hit the continue button right here, this allows me to continue the program. You can also see the state of all the variables down here. So n has a value of 123. Last digit has a value of 3, right? We pulled that value of 3 off. If I continue the program, you'll see that we just called print_int again, and so we stop again at the next print_int call, right? Now, n has a value of 12, last digit has a value of 2, right? I pull off that value of 2, and the value of n was 12. All right, so now, if I continue one more time, you can see that we finally hit the put_char command at the end. So what happened? Well, we went through all the calls of print_int, right? And we now had a value of n, which was 1, and now we're going to print it out. So we stop there before we do. All right, now a neat thing that you can do with Xcode is that you can actually see what are known as the stack frames of all this. So you can look on the side and you can see all these calls. So we have 3 basically kind of instances of this print_int function call that we've made. So we started at main, we made the first one where last digit was a value of 3, n was a value of 123, right? And if I keep going up, you can see the changes that are made. So this is the top, top function that we're on. So this is this stack frame. And whenever I continue this program, you'll see that this stack frame will be popped off. So we're now done with that function, right? You just saw that it went away because we were done executing that printInt call. Then we returned, right? That printInt was done, and now you can see that our value of n is a value of 12, and our last digit is value of 2, because we're just back to that same function that we had before. So now if I continue the program again, after we print this digit out, this call to printf is done. So then we return back down to this one right here, right? So we can see that if I hit continue, now we've lost that call, printInt was done, and now we're back down to the last printInt, or the very first printInt call we ever made. And we are now printing out that last digit right here, and we can continue, and now we're done. So we've made all the printInt calls, and as you can see, we get that value of 123. All right, so anyway, I hope that helped you, understand recursion a little better. If you were wondering how I enabled breakpoints, you just click on the side, and you can right-click to delete them, or go up to the breakpoint section up here and kill them off like that. Anyway, that's hopefully a good introduction to recursion, and maybe we'll have some more in-depth tutorials on some later and more advanced topics in the C section. But I haven't really decided that. I'd like to get back to the Objective-C Cocoa stuff. But anyway, I'm going to conclude this, and if you have any other questions on this tutorial, feel free to leave your questions in the comment section below. Please subscribe to the channel or Twitter and Google+, and you can always ask me questions there as well. Anyway, hope you enjoyed it, and I will see you in the next tutorial.